Yeah, so good evening everyone. We are team TB.ai. So we are the leading technology in the tuberculosis and participating in this AIT SDG, AIT Summer School SDG. And so our main focus is on only like SDG 3, that is SDG goal 3, good health and well-being. So coming to the point, this is our agenda for today. So we will be covering that why TB we focus first, and then the major focus is idea flow and about our team. So this is the stats that I want to share with you, that TB also comes in a form of death amongst death is very much higher in TB also. So we need to focus on that part, and 1/4 of the global population is infected from this tuberculosis, and it is spreading in a wide range right now. So coming to that, why tuberculosis? First question, like why should we focus on TB right now? So coming that, it's like one of the infectious diseases that affects the lungs directly. That is our respiratory system directly, and we also know that it is curable disease, and it is like the WHO also has said that by 2030 they want to they have introduced end strategy for TB at the same time, and also they are working on MDR TB, that is multi-drug resistance TB, because that also remains a public health crisis for right now. So according to the overview over the world, we can see that the Southeast Asian countries are facing right now a much problematic TB in this this data is April 2021, which is currently available. So what is our major focus? So our major goal is to decrease the number of TB cases by the year 2025. That is, we are working on the strategy with the WHO, that is to end the end of TB at that point. So this is our goal, ultimate goal, to work with this part. So what is TB.ai? So TB.ai is basically a very simple thing, that is an integration of digital solution for tuberculosis, and it also works on the deep learning model. So this is TB.ai. So why do we need TB.ai? So we need TB.ai because, like, according to WHO, that is end strategy pillar 1, which is very basic pillar, they have shown that pre-screening is much more important right now. So we kept our focus on pre-screening as an important factor. So we focus only on pre-screening for right now. So this is the questionnaire which is filled by the people when they go for treatment, and we focus only on the pulmonary tuberculosis right now. We don't cover all tuberculosis, but we are mainly focused on pulmonary tuberculosis right now. Coming to the next point, like the overflow of our working system. So we also have the image. So this is our deep learning model that we are using, and this is how we get the into two forms, which is very much understandable, that is normal and tuberculosis. So we need X-ray as the input part for that one. Coming to the this is how we did this. Like, we took the original X-ray, segmented mask and segmented lungs, and then we had data set which had total 3,500 parameters for training. Coming to the next part, like VGG16, this is our accuracy, and we had two classes, class 0, class 1 with the prediction. Class 0 means like very less chance of TB, and class 1 means very high chance of TB in the X-ray. Similarly, we use ResNet model, that is thematic X-ray vision, for the clear accuracy. So we got 99% accuracy in that case. And we use MobileNet version 2 for the negative detection and the positive detection at the same time. So we got accuracy almost 99% at the same case. This is the accuracy graph. So this is a small working of our so this is our web-based analyzer, where we take X-ray as an input, and then we get here the chances of tuberculosis and the normal at the same time. So you can scan, and you can also visit that part. So next we have a web-based analyzer for the people, like they can also see on the web screen that what is the current scenario of tuberculosis worldwide. According to the region also, they can see that in their country, in their region, what is the tuberculosis rate right now, and what is the growth, what is the decline. This can be used by the governments at the same time. This is for the vaccination part, the same thing. The vaccination can be also seen at the same time. that how much according to the year, which year they want. This is all sources we have taken from WHO for this month. So our target is public benefit, hospital and health ministry. Our revenue comes mostly from the IT healthcare, like IT healthcare and small clinics. We will be giving this for them, and we have a lot of benefits of our technology, that is economical, early stage screening and country development. So for the future, we have our target to end the TB by 2035 as per the WHO policy, that they are also working on the same thing. So this is what we suggest. And coming to our teammates like me, my teammate Salman, and we have our mentor Professor Dr. Rafael here at the same time. So thank you. Feel free to ask any questions if you have.
So your product already exists? The product you're proposing?
So actually we don't call it a product, we just call it a technological solution. We are not a product designer here actually, we just provide technological solution to existing things right now.
Yeah, but this TB.ai, does it exist?
TB.ai actually it does not exist right now. This is
you are showing some accuracy level actually.
Yeah. So that is the data set which we have taken, and we are trying to run in the algorithms. There are few algorithms which we are trying to run on right now.
We have the code and the data for the three
Yeah.
algorithm. Like we can test new X-ray. If someone give us the picture of X-ray, we can test it either it's TB patient or non-TB patient, because we already trained with 3 models.
So you basically analyze X-ray.
Yes.
X-ray.
We focus on pulmonary TB, that is done by X-ray, and the web-based solution for the government and the public at the same time.
So, but usually, I mean, there will be a doctor who look at the X-ray, and he does your job. You will substitute the doctor.
We are not substituting the doctors, but when the patient goes first, it's not only the stage 1 that where they take X-ray. At the same time, also they have to go for blood testing and these things at the same time. But if we have X-ray part at the same time, the results are given very much fraction. Like within a second, you can get the results at the same time. Because X-ray comes also in digital form right now. I can say that it's not only in the paper that we see, it comes in a digital form.
Right.
So it's easy for patient to also monitor them by themselves, not going to the clinics or something else.
By themselves. But where they do the X-ray?
Actually, the TB real test, what doctor suggests is from sputum or from blood or from muscle scratch test. But what we suggest is like, if normally X-ray, if someone is taking it, usually doctor doesn't suggest the lungs test or X-ray, because it is like in severe stage, the sputum appear in the lungs by X-ray. So in the initial state, you can't detect it by visual inspection. Only the segmentation and classification is done by deep learning models. They can detect.
So how selectively you can detect? Because the lung is
Yeah, so right now, like we are saying, like we work on the data set and we got like around 90% accuracy, I can say. So the more number of samples we train, the more number of accuracy, the more model better it becomes.
But the 3500 data set, that data set is from whom?
That is like sources we have given here. Like these are like medically certified data sets. These
Yeah.
are the data sets: NLM, NIAID, RSNA, and this one.
Yeah, but these are all TB data set from
Yes.
TB patients.
Yes.
But there are
But it is all,
TB patients.
all,
Yes.
all are TB patients, right?
Normal
No.
TB.
Like they have like training and validation at the same part. Different, 30-70. So 70% we have to train, 30% is validation.
So usually you use a set of data
Yes.
that's verified by
Yes.
the doctor.
Yes.
This is TB, or here in the lung you can see this is
It
this,
is-
they
it
can
is
annotate
very-
this. And that is what you use usually for AI.
Yes.
Because I do the same thing but with some of my colleagues in Singapore.
It is medically certified. The doctors which medically certified data, they share this for this part, and we just train with the
So with this data you train your algorithm,
Yes.
and then you can use any X-ray.
Yes.
No, this is the X-ray. So students know, can this go to other types?
Yes, sir. So for this case, when we have like very free screen, like suppose for example we don't have X-ray, but there is a questionnaire which I showed you before, that we have a questionnaire to be filled at that time. So with that one also we can say that there is a chance. I don't say 100% but a chance, because location also matters at the same time. So if a person comes from the location which we showed on the map, which shows that okay, for example, I take like India as one of them. So there is a chance that he or she might have TB because he has that symptoms. So with that we can say. But if a person is from Europe or some another place where there is very much less TB, like less than 10%, so we can say that okay, there is a chance that he or she may not have TB, they are suffering from another. But X-ray can make it conclude that part that okay, they have TB but they don't have TB.
So if you were to ask using your technology, how much would be the percentage of efficacy or accuracy you can provide or you can ensure?
So using this, if you have X-ray, so definitely more than 80%. But if you don't have X-ray, we can just give a chance, like less than 50 also, more than 50 also at the same time.
So it's going to be used with an X-ray image and also without.
Yes, like in the video we showed, right? We can take X-ray image as an input and it gives directly the output. So this is, you can scan and also you can visit, like this is built actually. Yeah.
And how you plan to do the business?
So business we are planning as a social service for this one. Like we are not too much focused on the money perspective or something. So that's why we are not calling it as a product right now. We call it as a technology for this part. So that like we can give it to the hospitals. We can give them at some
For
price.
free.
Not for free, but like something like minimal cost, because this is a social service that we do. So social service is also very much important. Yes.
We already compared the prices, like normal TB test is almost 4,000 to 2,500 to 4,000 and the X-ray cost is like 800.
Okay, thank you very much. Okay, so you know.